guys, so like I said, we are going to start with our new topic, our new course, and this is looking at whole numbers. Now, what you'll see here is, let me just do this a bit better. What you'll see here is I've actually got the whole number system outlined for us here. Now, we don't have to know all of these right now, but it's important to understand where whole numbers fit into our number system, because we don't just work with one type of number. We work with lots of different types of numbers. Now, in maths, for the most part, we use what we call the real number system. And basically, real numbers are numbers that, I don't want to say are real because that's a very poor description of it, but basically numbers that we can use in some sort of logical way, that have some sort of concrete meaning for us. So for example, something like a fraction. A fraction, we can understand what that means. If I say, I don't know, you are getting half of the pizza, you understand what that means in relation to the whole. If we think about negative numbers, if I say it is minus 10 degrees outside, we can understand, we can sort of imagine what that is. We do get another type of number system called non-real numbers. We do not need to stress about that right now. We very rarely deal with non-real numbers, but these are numbers that we can't really imagine what they mean. They don't really have like a concrete meaning for us, but we don't need to stress about non-real numbers. What we are going to focus on is real numbers. Real numbers, basically 99% of the numbers you are going to deal with in maths are going to be real numbers. So this little picture over here, and I'm just going to make this bigger to start with, sort of shows you how the number system works. You can almost imagine it like measuring cups or like balls that fit into each other, that sort of thing. But basically, we get real numbers, which encompass all of the numbers that we work with. And then we start to specialize our numbers as we deal with different groups. Now, we're going to focus mainly in this course on whole numbers, natural numbers, which I'm going to explain now in a second. But you get lots of different types of numbers. We've already mentioned a couple, but as we go through this course, we're going to talk about specific types of numbers as we go along. Okay, so the first one that we're going to define for ourselves are natural numbers. You'll see on the side here, I've got the headings, I suppose, of each of these. And our first numbers that we want to know what they mean are natural numbers. Now, natural numbers are basically what we can call our counting numbers. So when you learn to count, these are the numbers that you work with. Now, when we learn to count, we start from 1, 2, 3, 4, 5, and so we keep going. And so your natural numbers are those numbers, 1, 2, 3, 4, and so we keep going, and you can keep going all the way up into infinity. So your counting numbers are your natural numbers. Now, another important thing to note, and you don't have to stress about this too much at this point, I'm just going to tell you as we go along, is that each of these types of numbers have a symbol, a mathematical symbol that we can use to represent them. Now, natural numbers, their symbol is basically just an N. Sometimes it's I don't want to say a fancy N, but it's it looks fancier than a normal N. I don't know how else to say that. The way I draw it, and I haven't drawn it very well here, so let me try it again. The way I draw it is basically an N with like a double line in the middle, like that. And that is the symbol for natural numbers. Now, the reason that that is an important thing to note is because when you start to deal with different types of numbers and we start to deal with more and more groups of numbers, often because mathematicians are quite lazy sometimes, they won't write out natural numbers. They'll use the symbol. And so just knowing these symbols as we go along are quite important to note. Right, so your counting numbers are your natural numbers. These are all the numbers 1, 2, 3, 4, 5, all the way up to infinity. Because mathematicians also like to be quite difficult, they created a whole new grouping of numbers to include one extra number. So whole numbers basically are your counting numbers, but including 0. So it's 0, 1, 2, 3, 4, and so on, all the way up to infinity. So we've got a whole new group to just include 0. Now, yes, mathematicians like to be complicated, but it's also because 0 is quite a special number. We know that if we multiply something by 0, we end up with 0. If we divide something by 0, we end up with, if we look at our calculator, a math error or no solution. So 0 is a little bit of a special one, and so we've got a whole new group to include 0. So whole numbers are your counting numbers plus 0. Now, again, mathematicians sometimes are very creative, but also sometimes not. Because it's all of the natural numbers plus 0, the symbol for whole numbers is basically the n with a little 0 at the bottom to show that now 0 is included. So when we're working with whole numbers, if we want to express that using its symbol, it's the n plus a little 0 at the bottom. Okay, I see on the chat, some people are struggling to hear me. Is anyone else struggling? If you can hear me, put a thumbs up.
So I can hear you on my side, and I'm busy talking and chatting to individuals on what they should do to hear you.
Okay, cool. I also see some confused faces, I'm going to be honest. So hopefully we can sort it out. Alrighty, guys. So whole numbers, this is what our course is going to focus on right now. Sort of for the next, 3 weeks, we're going to focus on whole numbers. Now, okay. I'm going to explain the other types of numbers just because you're eventually going to use them and we're eventually going to talk about them. And being able to put numbers into their correct groups is going to be very important. So the next type of numbers that we need to be mindful of are what we call integers. Now, we've sort of mentioned integers very briefly when we were doing a revision of grade 7, but integers are basically all positive and negative whole numbers. Yeah, I'm using some shorthand here, so if anyone doesn't understand what I'm writing down, just let me know and I'll tell you what I've said. So it's all our positive and negative whole numbers. So this you can sort of imagine like your number line. Obviously my number line is beautiful. We go, and I'm going to try that one again because I don't actually like it. We can go all the way from negative infinity all the way to positive infinity, and we've got all of these numbers in between. But integers are the positive whole numbers, so 0, 1, 2, 3, all the way up to infinity, as well as the negative numbers, so negative 1, negative 2, negative 3, all the way up to negative infinity. So integers now include the negative whole numbers. That is then slightly different to our whole numbers and our natural numbers. So I'm going to give everyone a second to just, if they want to screenshot that or get it all copied down, that's cool.
Light has her hand up.
Okay. There should be a little pop-up to unmute.
Hi, you can talk to us for light. Now we can hear you, so you can talk to us.
Hello.
Hello.
Hi. How are you?
We're good. How are you?
Paulette says she don't understand. She say you speak loud, you speak quickly.
Okay, I'll slow down.
Okay. Thank you.
No problem.
To everyone, before Teacher Sam continue, if you know where you're getting lost, you can raise your hand and just tell Teacher Sam, oh, I didn't understand where you say whole numbers, what was the difference? And it would be nice for you to take a screenshot because this is like a summary of everything there, and it's nice for you and done, and you can revise it every single time, okay? Because this is really, really important for you guys to know.
Okay, so I'm just going to go through those again, just that we're all on the same page, because these 3 groups of numbers are the the really important ones that we need to know, grade 8 and grade 9. So your natural numbers, these are the counting numbers. These are the numbers that you learned to count with. So these are the numbers from 1, 2, 3, 4, 5. If you think about just counting in ones, those are your natural numbers. Okay. Your whole numbers are almost exactly the same, except now they include 0. So now it's 0, 1, 2, 3, 4, 5, and so on. Those are the numbers that we're going to focus a lot on in this course, the numbers from 0 to infinity. No fractions, no decimals, no negatives. We're going to just focus on positive whole numbers. The next group of numbers that we need to know about are integers. Now, integers are all your negative and your positive whole numbers. So if you think of your number line, if you go all the way from negative infinity and you keep counting, so -5, -4, -3, -2, -1, 0, 1, 2, and you keep going all the way up to positive infinity, those are all of your integers. So integers now include negative numbers. And this is another type of number that we are eventually going to talk about. So that's why I'm mentioning it to you now. Integers include negative numbers. Okay, we do have two more groups of numbers, rational numbers and irrational numbers. I'm not going to stress too much about those right now, so we're not going to write anything down for those. We'll chat a little bit more when we start to do fractions. But basically, rational numbers are numbers that you can write as a fraction. Irrational numbers you can't write as a fraction. But we'll chat about those more when we get to fractions. So don't stress about those. All you need to worry about right now are the three types of numbers that I've listed there: natural numbers, whole numbers, and integers. And like I say, what we're going to focus on in this course are whole numbers. Okay, so I'm going to just hang here for 2 seconds, hoping everyone's got their screenshot. Okay. Okay, so guys, this is sort of whoopsie daisies. We'll get there. A number line is a very important tool for us to use when working with really any type of number, but mostly whole numbers and integers and so on. Now, the reason it's very useful to us is because when we start to perform operations with these numbers, when we start to try and understand what these numbers mean for us, having a number line is actually quite useful. It gives us an idea of whether a number is maybe bigger or smaller than another number. It gives us an idea of how big or how small a number is. Like I say, when we start to do operations, it helps us with our operations. And so you'll see very often throughout these first few courses, I'm going to say to you, if you're struggling, draw a number line for yourself. Okay, so we're going to look at this number line just very basically, and I'm going to ask you a few questions that you can either put answers to in the chat, or you can put answers to, or you can raise your hand. Sorry, I was getting there eventually. Okay, so my first question to you is, which number is bigger? Is 2 bigger or is 4 bigger? Which represents more? And you can put in the chat, you can put raise your hand, completely up to you. Which number is bigger? Nice. Okay, so most of us are saying 4, and I think I would tend to agree. I'd rather have 4 chocolates than 2 chocolates. Okay, so if we now compare another 2 sets of numbers, if we now compare 4 and 7, which number is bigger, 4 or 7? I know this seems a bit tedious, but this is all very important. Good, well done, guys. So 7 is bigger. And so what we're starting to see is that as we move up this number line, so as we get closer and closer towards positive infinity, that's a terrible infinity, let's try that again. We are dealing with bigger and bigger numbers. Now, this is important because again, when we start with our operations, so adding, subtracting, multiplying, etc., etc., it's important to understand, am I working with a very big number? Am I working with a very small number? What sort of number am I working with? Right, the negatives we're not going to deal with a whole lot in this course. We are eventually going to, so please don't worry. But I'm just going to ask you a couple questions based on negatives now so that we get the hang of it. So my first question, this might be a point where you might want to raise your hand, is in real life, where do we deal with negative numbers? So can someone give me an example of where in real life they have seen a negative number? Nastasia, I hope I'm saying your name correctly. If I'm not, you can correct me.
Ma'am,
Yes.
we see negative numbers. It's either in like the degrees, like we have negative 0 degrees Celsius. So
Yeah.
we see numbers that have a negative there.
Perfect. Excellent. Well done. So guys, one really important example of where we see negative values is exactly that with temperature. I mean, it depends where you live, I suppose. Sometimes in South Africa, we get some negative temperatures in winter, especially like more inland. Some people get like -1, -2 degrees, some very cold winter nights. But that's an example of where we get negative values. I saw in the chat, Sia posted bank accounts. Now, Sia, I don't know if you want to raise your hand to say a little bit more, so I'll give you a second or two if you want to, but otherwise I'll explain what that means. Okay, all right, so Sia's come up with bank accounts. Now, bank accounts is also a really important one when we see negatives, because negatives in terms of money implies debt. So think of it as you've spent more money than you have in your bank account, and now you owe the bank money. That is essentially what debt is. And that is actually where negative numbers, let's not say were invented, but where the need for negative numbers came about. When, this is not information you need to know, I'm just giving you a fun mathematical fact. When people started trading and started sort of using money and goods to trade, this concept of owing each other something came about, and this is when negative values came. And so finance is actually almost like the starting point of negative numbers. This concept of debt is why we essentially have negative numbers today. Okay, so we've got temperature, we've got debt, or in terms of money. Anyone else think of any other places where we use negatives? I'll be honest, I can't think of any. That's why I'm asking. I'd love to know some more examples. Negatives. If we get like really fancy, if we start going into like science and physics, sometimes negatives can represent like a change in direction and stuff like that. In maths, yes, indeed, we have negatives in maths, and this is all sort of what we're going to start talking about at the moment. Okay, so that's negatives. If we go back to our number line here, and I say, which is bigger, -4 or -1? Which value is bigger? Very nice, guys. Well done. Okay, so -1 is bigger. And again, this is where we can think about debt as our sort of reference point. And let's, I don't know, let's pretend I would rather owe someone 1 rand than I would owe them 4 rand. You would much rather owe them a little less. And so -1 is or represents the bigger value. And so what that means is, again, once we start to move down left along my number line, I'm getting into much, much smaller values. And so when it comes to integers and working with these negative numbers and these positive numbers, it's very important to understand what that number actually means to us. Right. So, oh, we're already halfway, guys. Look at that. So we're going to take a little break. Here's your brain break for the day. Now, remember, our brain break is a chance for you to get up, stretch, try the little puzzle thing that I have here. And just take a moment before we carry on with the rest of our lesson. In this case, our brain break is we want to move only 3 of these coins in order to turn the triangle upside down. I'm having a moment of feeling like I actually did this with you. Now I just want to double check myself.
Ooh, I don't remember that brain break. It's my
Okay.
first
Okay.
time.
Okay, never mind.
And we are on the new year. So definitely it's the first time.
Okay, that makes me feel better. Okay, guys, so these brain breaks, we'll do it differently every now and then, but basically try it. If you have an answer for us, you can put it in the chat or you can raise your hand. We love having you guys raise your hands to explain how you've done these brain breaks or these puzzles. We like to hear your voices. So I'm going to give you like a minute or two to think about it. Which coins can we move? And remember, it's only 3 coins can we move to turn the triangle upside down. As Jelena's pointed out, there's my math stroke for the lesson. If at any point you want to give our coin puzzle a try, again, put it in the chat or you can raise your hand. And all of these puzzles, whilst yes, are very fun, also help us improve certain skills that we need, whether it be in maths, just in life. So they're all here for a reason. So I don't know if this will help at all. Basically, what we now want is our triangle to point. Maybe I should draw a better triangle. Is our triangle to go down. That's what we are wanting. Even if you only know 1 coin that you would want to move, you can let us know. Don't have to have all 3, even just 1's good. Asecha, which one do you want to move?
Mama, I can see 2 that I can actually move here.
Okay.
The one that is on the right, down.
This one?
Yes, ma'am.
Okay. Where are you going to move it?
I'm gonna move it up.
1 row up or 2 rows up or 3 rows up? How many rows up?
3 rows up.
Okay. So to here or to here? Second one, 1 or 2?
2.
2. Okay. Sorry, clearly I'm just not doing well tonight. Okay, so we are moving this blue coin up here.
And the
What
one
other
that
one?
is on the left.
Okay. Also up.
Yes, ma'am.
Okay, I'm liking it so far. Any other suggestions, guys? Okay, so if you look at my beautiful yellow triangle that I've drawn here, I'm just gonna try go with that. And then I took the yellow triangle off. And I see another hand. Tingo, do you want to help us out?
Yes, ma'am.
Yeah?
Ma'am, I think yeah, you move the bottom to the bottom coin, the bottom right coin to the top.
Okay. Both of these two.
Yes, then the one at the top we go down.
Excellent. Well done. So guys, if we move the one at the top down and then those two bottom ones up, we've then got that yellow triangle that we wanted, and we've turned the whole triangle upside down. And so just by moving those 3 coins, we've changed the orientation of our triangle. Okay, so again, fun thing to do, but this helps us with things like spatial awareness. It helps us with things like shapes and geometry, all of which we're going to do in maths. And so these sorts of activities, fun to do, but also teach us a little something. Don't know if anyone wants to take a screenshot. You don't have to. These are not the things I expect you to screenshot, but if you do, I'll leave it there for a second. And then we shall move on. Okay, I'm hoping we got it. Okay, so guys, when it comes to whole numbers, I'm just gonna make this a bit bigger so we can actually see. There's some important things that we need to bear in mind when starting to work with whole numbers, and we're gonna start to do basic operations as we go along here. The first thing that we need to know is that the order in which we add or multiply whole numbers actually doesn't matter. So the order in which we add or multiply doesn't matter. And I've got a whole bunch of examples here for you. So I want you to look at A and B for me. And I feel pretty confident you can all find these numbers for me. So I'm going to give you like 60 seconds. I want you to tell me what 3 plus 4 is, what 4 plus 3 is, what 7 plus 12 is, and what 12 plus 7 is. So I want answers for those 4 sums there. You can put it in the chat if you would like to. Otherwise, I'm just going to give you some time to do it. And remember, guys, if you're struggling with this addition, draw a number line for yourself. I don't have a problem with calculators, but some teachers do say no calculators. So a number line is quite helpful sometimes. So if you are struggling, just draw a little number line for yourself. Okay, I'm seeing lots of answers coming in, which is awesome. Nice, guys. Okay, so I'm pretty sure you all know this anyways, but we know that 3 plus 4 is 7. And if we go on to the other side, 4 plus 3, so now with the numbers swapped, is also 7. If we go to the next one, 7 plus 12 is 19. And if we were to swap those numbers with 12 plus 7, we also get 19. And so what is important to take away here is that the order in which you add numbers doesn't matter. Now, the reason that this is an important thing to take note of is if I gave you a question like 3 plus 4 plus 7, let's say, for example, you can obviously do that however you want to, but what is important that we start to develop is an understanding of the relationships between numbers. So if I were to look at that, it doesn't matter what order I choose to add this in. And the reason that that's important is because I know that 3 plus 7 automatically gives me 10. And so sometimes what we like to do is we like to look for numbers that when we add together give us 10. So if I add those green numbers together, I get 10 plus 4, which we know is 14. You can obviously say 3 plus 7, 3 plus 4 gives you 7, 7 plus 7 gives you 14, etc., etc. But the point is, the more numbers you start to add together, just remember it doesn't matter in which order you add them. As long as you end up adding them all and you add, the correct amount of them, it doesn't matter. And so the order in which you add numbers isn't important. As long as you add them all, whichever order you choose is completely up to you. Right, you can see in the chat, Message is put in the, I could never say this word. This is the commutative, I should be able to say it, but I can't. The commutative property of whole numbers. Exactly. It's essentially saying that the order in which we add numbers doesn't matter to us. Okay. This concept will become important later on in life, but just take note for right now, this order when we add doesn't really make a difference. The same thing applies when we multiply. So again, I'm going to leave this up in case you want to take a screenshot, although I think most of you probably have it. If we now go and multiply two numbers, again, this doesn't matter. The order in which I multiply or add numbers is not important. So again, I'm going to give you 60 seconds to just go and multiply those values for me. So I want the product or the answer I get when I say 6 times 4 and 4 times 6, and the answer of 12 times 3 and 3 times 12. Sorry. Okay, I'm seeing some great answers. Well done, everyone. So if we go to 6 times 4, we know that that's 24. And when we go 4 times 6, and the numbers swapped, also 24. 12 times 3, we know is 36. If we swap those numbers, 3 times 12, we still get 36. So again, the order in which I multiply isn't important. Now again, this is important to take note of, is because if I were to give you a sum of 3 times 4 times, try not to make our lives too hard here, let's say times 4, whatever order you choose to do that in is completely up to you. So this now goes back to how comfortable you are with your times tables. If, let's say, for example, you're comfortable that 4 times 4 is 16, you then just have to multiply 16 3 times, or add 16 3 times. If you wanted to work with 3 times 4 is 12 and then times that by 4 to get 48, that's fine. But the takeaway here is that the order in which you multiply things doesn't matter. Not important. You do it in whatever order you want, as long as you're multiplying everything correctly. Okay, it's just decided to take a break. So when we multiply, when we add, order is not important. When it comes to division and subtraction, the order is important. And that's now something we need to bear in mind. I'm waiting here for 2 seconds in case anyone would like to take a screenshot before we carry on with that thought. But addition, multiplication, do it in any order you want. Division and subtraction, you have to do it in the order we give it to you. Okay, so this is my next statement. The order in which we subtract and divide is important. You can't just do it however you want to do it. You have to do it in the order that I've given it to you. And now again, to prove the point, I'm asking you to find me the two answers here. So the first question is 3 minus 4. So take 4 away from 3. And the next is 4 minus 3. In question B, 7 minus 12 and 12 minus 7. Again, if you guys are struggling a little bit, draw a number line for yourself. What I actually will do is put a little number line up here so that you can use it in case you need. But a number line is always a good idea. Obviously, if you are allowed to use a calculator, by all means use a calculator. But not everyone is allowed to use a calculator, so sometimes it's helpful. I may have overcommitted to the size of this number line, but it's okay. I think I have very much, but anywho. Okay, there's a number line in case you would like to use it for your subtractions. You can already see some awesome answers coming through. My number line looks a little bit aggressive so long, so I'm just going to make it shorter. Don't fight with me. Excellent, guys. Some good answers coming through. Right, if we start with our first one, 3 minus 4. Now, I'm going to show you how to use this number line in case you've forgotten. We start with the value we've been given first, so 3, and I want to subtract 4. So I go minus 1, minus 2, minus 3, minus 4. Where I end, that is my answer. So the answer to 3 minus 4 is -1. You can do your number line with addition or subtraction, doesn't matter, up to you. So if we now go to the 4 minus 3, I start at 4 and I subtract 3. 1, 2, 3. Where I end is my answer. Now, what's important to note here is that we've got two very different answers here. One is -1 and the other is +1. And so again, using this number line, we can see that these are in fact two different values. If they were on the same number, then cool, same answer. But one is negative, one is positive. And this is why the order in which we subtract is very important. If you switch the numbers around, you're going to get a different answer. And so it is very, very important that we take note of what order we have to do our subtraction in. Right, a lot of you have also given me the answer for the second one. So if we start with 7 minus 12, I'm starting at 7 and I'm subtracting 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I end up at a -5. If I now swap those values around and say 12 minus 7, I've obviously now put 12 on my number line because my brain's clearly working very well today. So if I go up to 12, get in there, slowly but surely. All the way up to 12. I get my pen right for most of the lesson and then it's just chaos thereafter. Right, 12. I now want to subtract 7. 1, 2, 3, 4, 5, 6, 7. I end at 5. And so my answer there is 5. Now again, two very, very different answers. I've got a -5 and a +5. If I look at it on my number line, they're in two completely different places, two very different answers. The order in which you subtract and divide, we're going to get to division in a second, is very, very important. I'm going to leave it up there for a second in case you want to take a screenshot. Okay, so if we now come to division, now we are not focusing on fractions in this course, so I'm going to do these two with you just so that you can see the point I'm trying to make. When we eventually get to fractions and so on, we'll focus a little bit more on this. But division is another one where the order in which you do your work is very important. Okay, so if we start with our first one, we know that 6 divided by 3 is 2. 3 can divide into 6 twice. This goes back to our times tables, in that we know that one of the factor pairs of 6, or one of the pairs of numbers that we can times together to get 6, is 2 times 3. So my answer there is 2. Now, if we look at the second one, another way we can write division, we know, is to write it as a fraction. So technically, this is 3 over 6. Now, the reason I'm writing this as a fraction is because we've already had a conversation about how you can simplify fractions. Or last year, if you missed the first few lessons, you would have known or would have been told that you always need to simplify your fractions. Now, if we look at this fraction, we know that both 3 and 6 can be divided by 3. So if I divide both the numerator, so the top, and the bottom by 3, I can simplify my fraction. So I know that 3 divided by 3 is then 1, and 6 divided by 3, we've already said, is a half. 2 very different numbers. Again, if I imagine this on a number line, and I'm not going to draw a perfect number line here. So there's 0, 1, 2. One of my values, let's do this, is here at 2. That was aggressive. I do apologize. Let's not do that. One of my values is here at 2, but my other value is at a half. So in between 1 and 2. Again, 2 different values. And so the order in which I divide numbers is very, very important. One, generally, it depends how they divide. One gives you an improper fraction or a whole number. The other gives you a fraction, just a normal common fraction. So order in which you divide, very important. I want you to try D for me. So try for me the 12 divided by 4 and the 4 divided by 12. If it helps you, you can write these as a fraction for yourself, just to get the division sort of sorted for yourself in terms of what it's asking you. So that would be 12 over 4, and this would be 4 over 12. So you can give that a try. I have also just seen a message asking for the quiz results. Unless I've missed something, I don't actually have the quiz results from last week. I am just going to double check myself. Usually what will happen.
Yeah, those will be up. I think they notified us on the group, on the WhatsApp group, that those will be up. They'll be up on Wednesday or something, so we can give it to you guys on Wednesday.
Okay, so I need to read my messages better. Yes, as soon as I have them, I will put them up. As Yolanda says, what we usually do is every quiz day, we give the results of the last week. So every Wednesday, I will give the quiz results from the last week. Okay, Masesh has given us an answer here in the chat. Very nice. So if we go to the first one, we have got 12 divided by 4. Again, if you think back to your times tables, this is now another factor pair that we know. 4 times 3 gives us 12. And so our answer here is 3. 4 can go into 12 3 times. Now, if we go over to our other one, 4 divided by 12, we can do a very similar method over here. We know that we can divide both 4 and 12 by 4. And so what that means is I can simplify this fraction. 4 divided by 4 is 1, and 12 divided by 4 we know is 3. That's a weird looking 3. Let's do that again. Didn't get better. And so we've got a third. Now again, the order in which I divided was very important. I'm either getting a whole number 3 or I'm getting a fraction, a third. Those are 2 very different things. I would much rather have 3 pizzas than a third of a pizza. So the order in which I divide numbers is very important, and we need to be careful when we do that. So sorry. Right. I'm going to leave it there for you to take a screenshot if you wouldn't Want to? Okay, and then to lead us end us off, I'm going to give you 3 questions. Apparently, I'm just going to do whatever I want here, where I want you to add some numbers for me. Now, remember, it doesn't matter in which order you add numbers. You can do them in any order you want.
Yeah, are doing really well. And Eunice, we can see that, but we have recorded the lesson for you. So after 24 hours, you can go back on the internet and just find this when you log in on Watobe, okay? So you can listen at your own time. So don't worry, everything is recorded.
Okay, so guys, 4 questions there that I want you to have a try of. When you put your answers in the chat, please just number them for me so that we know which answer you're giving. So either the answer for 1, 2, 3, or 4. If you need, use a number line as you go and do this. These are all whole numbers. There are no negatives here. This is leading us into what our next lesson on Wednesday is going to be. Give everyone another minute or so.
We also have a poll day today. Let's not forget, my pets. Don't go anywhere after this lesson so we can do polls.
Okay, I'm going to give you another minute and then we'll go through the answers and then we will have time for our poll. Right, and oh, sorry. Try to scroll on the chat, scroll the whole screen. Guys, the poll, as Yolanda said, please don't leave. It's very important for us to know in terms of how quickly or how slowly you feel the lesson's going. So please make sure that you do it. It will literally take you 5 seconds, not even. Right, so for our first one, I'm hoping that we all got the answer of 14. 8 plus 2 is 10, plus 4 is 14. I'm seeing quite a few 14s come through, very nice. In our next one, again, you can add this in any order that you want. 6 plus 3 plus 1 gives us 10. Question 3. Again, in my English, any order that you want. And I'm actually going to use question 3 as an example of doing it out of the given order. I generally, and you can do it however you want, I'm just giving you an idea of one way to do it. I generally try look for 10s. For me, 10s is quite an easy number to work with. So I can automatically see that if I said 8 plus 2, I would get 10. Then I'm just adding numbers to 10. 10 plus 11 is 21. And then 21 plus 6 gives me 27. So again, you do it however you want to do it. For me, one of the nice things about adding in any order is I can look for groups of 10, and then I'm just going 10, 20, 30, and then adding to my groups of 10. Right, in the last one, this is another example of this. I can see a group of 10. 3 plus 1 is 4, plus 6 is 10, and so then I'm just adding 6 to 10. So I get 16. So the last 2 specifically were examples of how you don't have to add in the order I've given it to you. You can, no one's stopping you, but you don't have to. But you need to start looking for ways to make these additions easier for yourself. Right, guys, you can see the poll here. Don't go until you have done it, please.